Let's talk about integrals of the form a1 over a plus b sine squared x plus c cos squared x by dx. Okay, so a, b, and c are constants. Now, the key to the method is to substitute. Okay, let me write this for you. So the key to the method is to substitute t equals to tan of x in the integral. Now, if t equals to tan of x, then we should obtain expressions for sine x and cos x. Remember your trigonometry, okay? When you define the ratios of a right-angled triangle, you say that tangent is opposite over hypotenuse. So if this angle is x, then tan of x is equal to t. Okay, we are saying the tan, that tan of x is equal to t. Of course, every number stands out of 1. So this is opposite, which is a t, and the adjacent is 1. Using Pythagoras theorem, this is the square root of 1 plus t squared. So we can read off sine x as opposite over hypotenuse. This is t out of the square root of 1 plus t squared. And then the cosine of x can also be adjacent over hypotenuse, which is 1 over the square root of 1 plus t squared. So we have used a right-angled triangle to be able to obtain expressions for sine and the cosine. So if we are changing the variables from x to t, then we also have to change dx. Okay, how do we do it? It is simple. Okay, we are saying that t is tan x. You want to differentiate both sides, so dt by dx is sec squared of x. So if dt by dx is sec squared of x, then we can say that dx is dt out of is dt times sec squared x. So let me just change this because I'm not really writing it so well. Let me change it for you and you can see clearly. So that I have my dx as dt over sec squared over x. But what is sec in terms of tan? This is dt over 1 plus tan squared of x, and we know that t is equal to tan x, so it's dt over 1 plus t squared. So we have dx changed in terms of the t, okay? And we have everything, so we can go ahead and perform the integral. Now let's look at an example. Let's discuss this example. You are required to integrate 1 over 2 sine squared x plus 4 cos squared x by dx. So we are saying that the key to the method is to substitute t equals to tan of x. Now, if t is equal to tan of x, we remember we have got expressions for sine x and but as a student, if you are given this question, don't again say, remember we obtained this during the lesson. No, you have to show how you get sine expressions for sine x and the cosine of x. I'll just go ahead and substitute since we have just done this in the first slide. So I will say that the integral of 1 over 2 sine squared x plus 4 cos squared x by dx, okay, will now be equal to the integral of 1 over 2 into this is t over 1 plus t squared plus 4 over 1 plus t squared, then times dt over 1 plus t squared. We have already obtained the expressions for sine and the cosine. Remember, right here, maybe, okay, I'll not waste my, since you can always refer. Sine is t over, so it will be a t squared. Since sine is t out of the root of, so it will be a t squared. Now, you go ahead and organize this, okay? This will be the integral of, if this is 1 plus t squared over 2t squared plus 4, then times dt over 1 plus t squared. At this stage, this will pack. Okay, that is the end of 1 plus t squared so far. Okay, so where do we go next? This is where it takes us. We have integral of 1 over 2 sine squared x plus 4 cos squared x by dx, okay, taking us to, it is now going to, this is equal to integral of dt over 2t squared plus 4. And we discussed these integrals, integral that involves tan substitution. So at this stage, you can let 2t squared is equal to 4, maybe tan squared of u. So that t is the root of 2 times tan of u. Okay, so that means that I can substitute back whatever I want to substitute in terms of, okay. So if t is equal to that, then I will have dt is root of 2 sec squared of u by du. Okay, but remember sec squared is 1 plus tan squared, so I can write this as the root of 2 into 1 plus tan squared du by du. So the integral will be equal to, this means that our integral, which is 1 over 2 sine squared x plus 4 cos squared x by dx, now taking us to the integral of this root of 2 into 1 plus tan squared du by du all over 2t squared is 4 tan squared of u plus 4. So go ahead and do the factorization. Okay, root of 2 over 4 can be written as, 4 is 2 times 2, so 2 cancels out, and we can write this as 1 over 2 root of 2, then integral of du, because 1 plus tan squared cancels out, it is up and down. And what's there? What do you get? You get 1 over 2 root of 2 of u plus sc. So we now make a back substitution. What is u? Okay, u is the tan inverse of something, or t, and it is tan of something. So let's do that, and then we shall be done. Let's look at the second example. Okay, we are having integral 1 over 2 cos squared x plus 1. Remember that we said that the key to the method is to let t equal to tan x. Okay, so if t is tan x, then we have gone ahead to show that sine x is t over the square root of 1 plus t squared, and we're also able to show that the cos of x was 1 over the root of 1 plus t squared. We have done that. But in an exam, you have to show, okay, you have to do the triangle, or whenever you're answering a question, you have to do the triangle, come up with the value, with the expression for sine and cosine, also change the x in terms of dt, okay? But we have done that, so I don't want to repeat myself. What else have we done? We have been able to show that dx is dt out of 1 plus t squared, okay? As a student, don't say, we have done this. Do it so it is part of you. You know, passing an exam or mastering the subject is after you have done things repeatedly. You know, the brain is like a muscle. If you give it an exercise and if you subject it to continuous exercises, it, you know, adapts and it becomes a part of life. So by watching me do this, it is very simple for you. You appreciate what I'm doing. But if you're given a chance to do something, that's when you try to gauge and see the level of difficulty. So it's like a football game. You know, when people are playing the football, you can easily identify mistakes, you enjoy the game. But if you're given a chance to go in the field and show what you have, I'm telling you, it's not really something that is easy. So let's do a lot of practice. Okay? Practice, practice, practice. It will make you perfect. Now, we are doing this integral of 1 over 2 cos squared of x plus 1. Let's make the substitutions. Okay, so what does this mean? That the integral of 1 over 2 cos squared x plus 1 by dx will now change to the integral. Dx changes to dt, okay, out of 1 plus t squared. So this is going to be 1 over 2 over 1 plus t squared plus 1. Then this is dt over 1 plus t squared. So what do we get? So if you go ahead and find the LCM down here, okay, you get 3 plus t squared, and then the 1 plus t squared goes up, and we get, so in other words, we obtain this expression on the next page. Okay, so what do we get out of this? Okay, the good news is that this is going out, and we are remaining with the integral of dt all over 3 plus t squared. So these integrals we always got to turn substitution. So what do? Let, okay, t squared is equal to 3 tan squared of u, so that t is root of 3 tan of u. Okay, so change, okay, change dt in terms of du, dt by du, okay, is equal to root of 3 sec squared of u by du. So, you know, we can write this as root of 3 into 1 plus tan squared du by du. So, make the substitution. Integral 1 over 2 cos squared of x plus 1 is now equal to the integral of 1 over 3 plus 3 tan squared of u times root of 3 into 1 plus tan squared of u by du. Okay, what do we get? Okay, this is root of 3 over 3 integral of 1 plus tan squared u over 1 plus tan squared u du. Okay, what do you end up with? Equals to 1 over root of 3 integral du. And what do you get? 1 over root 3 of u plus c. So at this stage, you start making the back substitutions. Okay, this is equal to 1 over root of 3. So how do we get u? You are going to get u from this part. Okay, it is t over root 3, then take the tan inverse. So this is the tan inverse of t over root of 3, then plus sc. But remember, t, okay? Oh, no, I made the, okay? Remember, we used the t was equal to tan x. So this is equal to 1 over root of 3 tan inverse of tan x over root of 3, okay, plus a constant of integration. We can now see that therefore, we can write here that therefore the integral gives us. All right, ladies and gentlemen, I have been Erisa. I want to take you through integral calculus, and this was the 12th lesson. So don't forget to subscribe and to hit the notification bell. Please do share these links with your friends. The more likes I have and the more subscription is, the better for me. So I'm doing this free of charge for you. What you need is only mobile data or Wi-Fi, and then you access the information. My brother Jonah in Komamboga, okay, that is, I think, Gaya's outside. I hope this works out for you and you're enjoying these lessons. Greetings to everybody. Make sure you share the links with your friends and, let's help each other in this difficult time. All right, ladies and gentlemen, have a nice day.